Okay, so I'm recording now, so you can see my face and my voice. I will stop my video now, and then I will continue to share screen. Okay. All right, so I'm doing my mathematician on Euclid. There isn't much on him in his life. However, he was born in Alexandria, Egypt, during the reign of Ptolemy I, and was born around 325 BC, and he passed away around 265 BC. He was thought to have studied at Plato's University, which had been founded in 387 BCE. The sign of the above the academy read, "Let no one ignorant of geometry enter here," as Plato was convinced geometry was the key to unlocking the secrets to the universe. Euclid was often referred to as the founder of geometry, or the father of geometry, as he is best known for the Elements. And the Elements contains 13 books that were allocated to Euclid, which he is also referred to, well, known as Euclid of Alexandria. That way he doesn't get confused with Euclid of Megara or Megara. And the Elements is actually referred to as the most successful and noteworthy textbook to have ever been written. The geometrical system that was explained and taught within the Elements was actually thought to be the only geometry possible. It was also the main mathematical textbook that was used until the 19th or 20th century. And for centuries, when the quadrivium was incorporated into the curriculum at universities for all students, it was required of every student to have an understanding of at least a part of Euclid's work. And if you don't know what the quadrivium was, it was a university curriculum that was used in the medieval times. It involved the mathematical arts, which included arithmetic, geometry, astronomy, and music. The Elements was considered to be one of the earliest mathematical works to be published after the printing press was invented, which the printing press is a technology of printing and typography that would use movable elements to reproduce the essentials of a document. The Elements include many different works, such as Pythagoras, Hippocrates, Theodotus, I could be saying that one wrong, and Theaetetus, I could also be saying that one wrong, and Eudoxus. The book contains 465 theorems and proofs that are all described in a clear and thoughtful way while using only a compass and a straight edge. Euclid reworked the mathematical ideas of his predecessors into a reliable piece of work, which became known as Euclidean geometry, which is still valid today as it was 2,300 years ago. Even in higher mathematics that deal with higher dimensional space, it is still valid. The Elements remains the definitive textbook on mathematics and geometry for over 2 millennia, while it also survived the Dark Ages in Arabic translations. The Elements set the model for mathematical argument following the logical deduction from logical assumptions, which Euclid would call axioms, and postulates in order to establish proven theorems. And Euclid has proved what has become known as the fundamental theorem of arithmetic, which is also known as the unique factorization. And it is where every positive integer greater than 1 can be written as a product of prime numbers, or it is itself a prime number. And Euclid was the first to realize and prove that there are infinitely many prime numbers. And the basis of his proof, which tends to be known as Euclid's theorem, is that for any given finite set of numbers, if you multiply them all together and then add 1, then a new prime has been added to the set. So 2 times 3 times 5 would equal 30. And then 30 plus 1 would be 31, which is a prime number. So this is just a process that can be repeated indefinitely. And then we have 5 of his general axioms. So things which are equal to the same thing or equal to each other. If equals are added to equals, the sums are equal. If equals are subtracted from equals, the remainders are equal. Things that coincide with one another are equal. The whole is greater than the part. And then another 5 of his geometric postulates. It is possible to draw a straight line from any point to any point. It is possible to extend a finite straight line continuously in a straight line. It is possible to create a circle with any center and distance. All right angles are equal to one another. If a straight line crossing two straight lines makes the interior angles on the same side less than 2 right angles, the 2 straight lines, if produced indefinitely, meet on that side on which the angles are less than the 2 right angles. The geometric postulates can get confusing when just reading about them, especially number 5. So this photo has a few it explains. It gives you a visual representation of what they're trying to say. So number 1 says it's possible to draw a straight line from any point to any point. So when looking at one, it has 2 points with a line going through it. So obviously you can draw a straight line from any point to any point. And then number 2, it is possible to extend a finite straight line continuously in a straight line. So you have a finite straight line and then a straight line going straight through it. And it's all on a straight line. And then it is possible to create a circle with any center and distance. So no matter what the radius is, you can create a circle. And all right angles are equal to another. So no matter if it's upside down or sideways or whatever, as long as it's a right angle, they will still be equal to one another. And then number 5 is probably the one that's more confusing, especially the way that's written out, I guess. It doesn't make the best sense. So if a straight line crossing 2 straight lines makes the interior angles on the same side less than 2 right angles, so these are the 2 lines that are crossing right here. Less than 2 right angles right here. The 2 straight lines, if produced, definitely meet on that side, on that which the angles are less than the 2 right angles. So they meet right over here. So this is where the angles are less than the 2 right angles. And basically this one, if you pay attention, has the little apostrophe. So it would be the negative, I believe, the opposite of this. So just instead of crossing, they would be in line with each other. So that concludes presentation. So yeah, that would be it.